Hi guys. So I know the video is dark and it's dark for a reason because I'm going to be showing you some things that light can do. A couple of weeks ago when we were finishing up the wave unit, y'all took some notes about different types of wave behavior. One of those types of behavior is called diffraction. Diffraction is when a wave kind of bends and spreads out around a particular barrier. So today I'm going to show you in this video some of the cool things that light does when it's diffracted. So the first thing that I'm going to do, we're going to be doing some things with flashlights and lasers, so that's why our lights are kind of dim. So the first thing I'm going to do is these are called diffraction glasses, and inside the lens areas here is what's called a diffraction grating. And basically what it does is it just takes a light and it separates it out into its colors. We know that white light is not really white. It's a combination of all of the different colors of the visible light spectrum. So red, orange, yellow, green, blue, indigo, violet. So remembering from your notes that red has the longest wavelength and then gradually shorter until we get up to violet. So first thing I'm going to do is take these diffraction glasses and put them over my camera lens. So you can see that things are starting to get kind of like almost a little shadow or an echo around them. So I'm going to show you what that looks like with this is just a plain white flashlight, and I'm going to shine it right at the lens. And I know it's bright, but you can see outside of that white spot in the middle how the colors are separating. So it's white all in the middle, and then as it starts to go out from that center point, we can see the spectrum. So violet closer in toward the middle, and then to green, and then orange, yellow, and red, and then it starts over again. Okay, if I back it up a little bit, you can see a little bit more of that spectrum. So that's a full white light. Not going to show it to you with the diffraction glasses gone because it's just a big white spot in the middle of the thing. But now I'm going to put different kinds of filters over my lens. So the first one I'm going to try is, I know it's hard to see, it's just a red covering. The intention of something like this is to filter everything but red out of the light. So here's what we see when we put the red filter on. Okay, you can see it's still kind of a white blob in the middle. Oh, there we go. Still kind of a white blob in the middle. Really, really red on the tips of those, you know, shards shining out, but we can still see a lot of yellow, a lot of green, a lot of blue. The next filter I'm going to put on is the blue filter. Okay, this one is working a little bit better. We can see some blue, lots of blue. We can see a little bit of red, a little bit of yellow, but it's lots and lots of blue. And the last filter I'm going to put on is the green. This one is a really good filter. It's almost completely green, a little bit of blue, a little bit of yellow, hardly any red in there at all. And then one more time for comparison is our white. There we go. That's the full white light. So I'm going to show these to you one more time. And on your paper, what I want you to do is just do a quick sketch in color if you can. If you can't do colors, like at least label kind of here's where it was red, here's where it was blue, of the different things. So this is the white flashlight. I'll try and get it to where it's not quite such a glare. There we go. So there's your white flashlight. And pause if you need to. Here's your red flashlight, or red filter, excuse me. So a lot more red, but we can still see the other colors. Here's your blue filter. And your green filter. Now here's the interesting thing. A laser, or a laser pointer, is specifically designed to only contain one wavelength of light. So I have a laser pointer right here, okay? I'm not even shining it at the camera at all. I'm shining it down. But you can see what's happening with the light. It's being diffracted, but it's not being separated into any other wavelengths because it only has one wavelength in it. Now what I'm going to show you next, still through the diffraction glasses, but this time I'm going to put the glasses over my laser pointer. So give me 1 second to get it set up. If I can get it to cooperate. There we go. Now, so I put this white paper up here so you can see it a little bit better. What I'm going to do is I'm going to mark what we're seeing. So right here in the very center, this is our center point. This is the brightest point of light. That's where the main beam of light is hitting from the laser pointer. But then it's separating it out into these gradually less and less bright points. I'm going to go ahead and mark a couple of those as well on our paper. Out from the center. And if you look real closely, you could see that they're a pretty uniform distance. It's spreading out really evenly across the paper. And as soon as I finish marking some of these, I will turn off the laser pointer. First remove the diffraction. So you can see I just took the diffraction glasses off, and you can see that center point where the beam is actually pointing. So here is where all of my red dots were. So the diffraction glasses spread out that red laser pointer into all of these different things. And you didn't see the colors on the red laser pointer because there's only one wavelength. It doesn't have anything to separate into except for to just make that light wave bend around the barriers that are in the glasses. And so now I want to show you a different color of laser pointer. So still just a single wavelength of light, but this time it's going to be green. And give me 1 second, I have to prep my green laser a little bit. I'm going to try and set it to where it's, that center point is in the same spot that the red one was. There we go. So I know that one's a little bit harder to see. It's quite a bit brighter than the red one. Now we're going to put our diffraction glasses, if I can make them stay. Sorry, you guys. There we go. So now, again, quite a bit brighter. The center point is in the same spot. And I'll show you as soon as I turn the laser off. But now I'm going to mark my green dots. And we'll see the difference in just a minute. Now, the other thing that you might notice, you can see those green dots actually spreading off of the paper off to the sides. And you might be thinking, well, how come the green one does that and the red one didn't? Well, the red one actually did spread out that much. It just because it's less bright to start with, those spread out dots were not quite as easy to see because they were very, very dim. Sorry, I had to tape my laser pointer on. And now I've turned it off. Okay. So, here's what I want you to notice. The center point is the same for both. There's a red and a green right here. But as we spread out, the next green dot is not quite. So that distance from dot to dot is shorter for the green light than it is for the red. The reason for that is because the red light has a longer wavelength, so it's going to have farther in between. As we get shorter with our wavelength, the green light has a shorter wavelength, so it's got a shorter distance in between. And one of the things I want you to think about that you're going to be answering in the quiz that goes along with this lab video, what would happen with a violet laser? Would the distance between our dots be shorter than the green or longer than the red? So think about that one, and hopefully this was interesting to you. I wish we could have done it in class. I really, really miss you guys. So just keep sending me questions and getting that work done, and we will push through and we will make it to the end of the year. So you guys are great. You're doing awesome. You're doing great. I'm really proud of you. Bye.